Hello everyone. Welcome to Docker. What is it? Why do I keep hearing about it for CodeLabs 2018? So, you might have heard of Docker, but before we go any further, let's actually explain what it is. So, traditionally, um, companies use VMs to uh, put their applications in and make them open to the outside world. So, if you wanted a website, you usually put that in a virtual machine and expose the ports that the website needs, and then put it out to the public web. But with containers, they're a lot more lightweight. That's because they share the kernel with the host system, along with the file system and some other stuff, and they boot up near instantly. So they're really good for ephemeral uses, and they're really good for keeping everything isolated away from the host system. And they're really popular because DigitalOcean did a survey and they found that containers are actually one of the most rising technologies from their survey. So let's take a look at how traditional VMs work. We have our host system here, represented by the white box, and we have our VM here, represented by the yellow box. So we can see our host system has its own CPU, RAM, file system kernel, OS, and some other stuff. This is a highly simplified example. And our VM has its own file system kernel and OS, but it shares the host system's CPU and RAM. And this makes it so that the VM has to boot itself up, has to do a bunch of things independent, and also uses a lot more resources than it would need if it was in container. So now let's take a look how this changes when we use containers. As you can see, the container shares the host's file system and kernel, and it still has its own OS. So this allows us to basically have our own little box that has all of our application inside of it, and it has all of its own dependencies, it has all of its own software inside of that container without ever touching the host system. This way, for example, one of my favorite things about containers is if you mess something up really badly, you can just get rid of the entire container and start over again. So you don't have to like reinstall your OS on your host machine. So let's go back to what Docker actually is. So Docker runs on images that are very similar to virtual machine images, and they're basically pre-built containers that are built by the community or by Docker, by whoever that the containers boot from. And they can be based off of any OS, like Ubuntu server, Alpine Linux, even Windows servers, if you want to use Windows. But images are little packaged, like basically files that have everything that your service needs to run. And these images are built with Docker files. We'll learn more about Docker files later. And one of my favorite things about Docker is Docker Compose. It lets you you just write all the services that you want to run in a file and how you want the containers for those services to be configured. And it will make those containers for you. It'll make sure they stay up. If you define that in the file, it will let you easily put them up, put them down, scale them, a bunch of other stuff. It's really, really nice. So let's take a look at some use cases. You can host websites with it. You can test stuff. You can use containers for development, which is really nice because you obviously don't want your development machine having a bunch of dependencies that you'll never use. And you can also run Docker inside of Docker if you really wanted to. And you can do basically anything you want with a VM. I say basically because there are some limitations, but they're very few. Let's take a look at a demo. Switch to something over here. 1 second. All right. All right, let's take a look at the Docker command. The most very simple Docker command you can use is Docker info. It gives you information about everything you have on your current Docker daemon. So I'm actually running this locally on my Mac right now. but we'll do a live demo where you can participate later. I just want to get the basics down real quick. So one of the commands you most frequently use with Docker is docker run. So this command tells Docker to run an image, and you can give it extra parameters like what command you want to run inside that image and stuff like that. So let's run the most basic image that you could possibly run, which is the hello world image that Docker provides to you. So I'm going to add this flag rm here. This tells Docker to remove the container after it's done running. So this makes sure that you don't have like dangling containers that are just stopped and taking up space. So I'm going to add that there, and I'm going to specify the image I want to run. So this command runs hello world and removes it after it's done. So it'll tell me it can't find hello world locally, so it'll go to Docker Hub and download it. And this is the image that we're downloading from Docker Hub. And there we go. We have our hello world and it's done. So I'm going to run that again, and notice how fast that it starts up. It's already done. It started up, it ran whatever it needed to run, in this case the hello world text, and it exited all within like 2 seconds. Much better than a VM. If we want to do something a little more ambitious, we can actually run an entire Ubuntu server inside of Docker. So I'm going to add some more flags to this. I'm going to add the I flag, which tells it that I want this container to be interactive, so I can continue using it. I'm going to use the T flag, so it gives me a TTY, so I can type commands and stuff. I'm going to re-add that RM flag back, and I'm going to use the Ubuntu image, which is also from Docker Hub. So I'm going to wait for that Ubuntu image to download. Honestly, building and downloading images is probably the most time you'll take on Docker. Everything else is super fast. So while we're doing that, I'm going to do something that I really like to do. So if I look at my containers that I have on here with the docker container ls command, you can see I have this docker craft container. I'm going to spin that up real quick with docker start. I'm going to show you a visual representation of Docker containers. So as we can see, we have our Docker craft container that's running inside of Docker, and then we have our Ubuntu image that we just made. So if we switch back to our terminal, we can see if I run who am I, I'm root, hostname, there we go. And this is entirely separate from my, my Mac. So if I run ls on our root drive, we have, wow, my fans are spinning up. If we run ls, we see that this file system is entirely different from my Macs. So it has its own file system, has its own files, everything. I think my Mac's gonna explode. The fans are spinning up so much right now. But as you can see, this is a really fun way to manage your Docker containers. It's also really visual. That's why we're using it here. But if we want to spin up more containers, we can do that. If I exit this, see, it'll remove it automatically. If we wanted to spin up another container, we can actually, let's keep this one on. So we have a bunch of Ubuntu containers. Let's talk about Docker Compose now. Now that we know the basics of containers and how you can use them in Minecraft for some reason. Hold on, let me get rid of these through Minecraft. This is the greatest thing ever. Oops, I broke the button. Guess we're gonna have to learn about the docker rm command. Docker rm o2. Poof, gone. Okay, I'm gonna quit Minecraft so my fans don't spin up. There we go, better. let's talk about Docker networking. So this is where we're going to the interactive demo comes in. So I'm gonna connect to our wonderful communal Docker daemon. So what this command does is basically just tells Docker to connect to our Docker daemon that we're hosting right now, since probably don't want to install Docker because Docker also needs I can't forget the name of it. Well, but it needs something on Windows that most Windows versions don't actually support. But I'm going to run that. So if we do Docker container ls, I have no containers. That's normal because this is on our communal instance of Docker. So what I can do though is to demonstrate networking, and if you guys want to do this, you're welcome to as well. I want to make a couple tabs here, and I'm going to go ahead and run an image that I made called Docker Chat, and it this demonstrates the networking abilities that Docker has because containers can talk to each other, and this image is built to it's built to talk to other containers in the same Docker daemon. So if I run this, take a while. There we go. It's going to ask me, what do I want to be known by? I'll put TJ. I'm going to go run the same command in a different tab. I'll put TJ2. Now if I type hello, oh, it doesn't work. That's disappointing. Oh, I know why. I didn't connect to the other Docker daemon on this tab. Let me do that real quick. Now it should work. Haha, there it is. So if I type in my messages, they'll pop up on everyone else's screen. And if you guys want to do this, your messages will also pop up here. So while people are getting on Docker Chat, I will continue talking about Docker files. So Docker files. I talked about them briefly earlier, and they're basically how Docker images are created. So let's go through the Docker file that I made for Docker Chat. Each Docker file is made up of just lines of commands like you'd normally see in like a shell script or stuff like that, but they're special. So this from command tells Docker, I'll just type it in chat. So this from command tells Docker where do you want to build this image from as a base point. So the Nodejs Foundation provides a Nodejs image officially, so I can use their image, and that's what I wrote this in. I wrote this in JavaScript, and it's running on Node.js, so it would make sense to get this image. One sec. There it is. See, it would make sense to use this base because Node.js is already installed and it has everything I need for stuff to run. So if I didn't have this, I'd have to make a long list of stuff that I need to do to install Node.js. But this workdir command tells Docker where I want my working directory to be inside of my container. So I want to mount my app inside of the /app of my container. So I tell it that, and then what I do to install my dependencies for Docker Chat is I just I copy all of my package.json and package lock.json, so npm knows what to install. The reason why I don't copy everything all at once at first and then just install the dependencies is because Docker actually has smart building. So when I want to rebuild this image, whenever I make changes, it will only run npm install if package or package.lock.json has any changes, because I don't want to have to reinstall the dependencies every time I make a change in every file. So that's why I just copy the rest of the files after I install the dependencies, which is done by this run command. And this command tells Docker what command to run by default when you run this image. So this isn't actually running anything at the moment. It'll just tell Docker what to run after it's done. You can put anything in here, but I tell it to run this command, which runs the index file with node. So, there we go. We have some messages on our Docker chat. Let's see, what do we talk about next? All right, let's talk about Docker Compose, my favorite thing. So I'm going to quickly make a directory called workshop, why not? And I'm going to make a file that Docker Compose uses to define services called dockercompose.yml. So inside of this file, we need to define some stuff. So I need to define the version that I'm using for Docker Compose. Hold on. There we go. So, and we also need to define our services that we want to use. For example, if we wanted to run a, what can we run? Let's run a, I don't know. Let's run a simple Nginx server. There we go. We have Nginx. So we can tell Docker what image we want to use. So we reuse Nginx. And that's actually all we need to do. So if I run docker compose up, it will grab the Docker Compose file. It will try to make all the containers it can from that file. And as we can see, it's creating the web service that we wanted, and it's downloading Nginx right now. Might take a while. Well, that's running. Let's take a look at some other larger Docker file or Docker Compose files. One sec, typing in chat. Aha, here we go. So we have Docker Compose successfully created our container called web, and it's attaching to it so we can see some logs, but there's nothing really happening in that container, so I'm going to stop that. But usually when you use Docker Compose, when you use Docker Compose up, you want to use the D flag, which detaches it, so you don't have to have your terminal up to see the output. So it creates the container, then exits Docker Compose. So we have, if I list our containers here, we have, maybe that looks better. We have our Nginx container, and it's running. But we need to define some ports for it to listen on. It's listening on port 80, right? But if we go to localhost, can't connect. It's because we haven't defined any ports in our Docker Compose file. So to do that, it's very simple. All we need to do is add another line here, name ports, and we add 80 to 80. So what this tells it is to open port 80 and on the container's port 80. So it's forwarding port 80 to the machine's port 80, because it's an entirely different network stack. So it needs to know where to put port 80. There we go. There we go. We have Nginx installed right there in our Docker container. Everything is contained within that container. Nothing's installed on our host machine. And it's if we delete that container by doing docker compose down, it's gone. No more Nginx. In fact, we can entirely just like delete this docker compose file, and there we go. No more Nginx. Easy cleanup, so you don't have to mess with your host machine. One second. All right. Now let's take a look at a really large Docker Compose file that I have made. There we go. Here's the really large Docker Compose file. I'm going to go through a little bit of what each of these does, but I have a service named bot, and what this does, what this tells it to do, is just build the image that's in the same directory as it, and this builds the web image. And this restart unless stopped tells Docker that I want to keep this container running. If it fails, like if it errors and it quits, it'll start it back up again. We have some stuff that I'm not going to talk about out of the scope of this workshop. But one of the interesting things is that you can run multiple services with one Docker Compose file. So we have 3 services here. We have a bot, we have web, and we have DB. So this database is running the official MongoDB image. And it's really nice because you can just you can define what you want. They can all be in separate containers, and you can tell Docker Compose that you want database to be running before you do anything else. And you're probably wondering, well, what if containers are ephemeral and you can just remove them? How am I gonna like store stuff in my database without losing it every time? Well, that's where volumes come in. Docker has these things called volumes, which you can attach to your containers and mount them somewhere. So I have this DB volume down here that I told Docker Compose to create, and I can mount it to Mongo's default database directory. And everything that's saved to data/data/db will be saved in this database volume. So every time this container is created by Docker Compose, I can use this DB volume, and that'll tell it keep this DB volume stored on my disk somewhere. All right, so that's about it actually. If you have any questions, ask in chat. I'll be happy to answer them. But I do have this document that you can take a look at if you missed anything in here or you want to learn more, because I did link to some articles down here. If you want to take a look, I'll put them in chat, and I'll put it in the student R&D chat as well. It's a good question, Tyler. Thank you for asking that. So I've used Docker personally to run basically every service that's on my home server. Actually, if we go to if we go to SSH into my home server, oops, actually, do that later. I use it to run basically every service on my home server, though. That includes all my Telegram bots, my GitLab instance, which is actually this is running on Docker right now, and it basically runs everything. So I'm actually going to go on this machine, SSH into my home server, and it's running so many containers I can't even count them. Around 20 containers. So it's running quite a lot of services, and it's very flexible, but each container is contained within their own little space, and they can't touch other containers except via networking if you want them to. So another thing you can actually use Docker for is that it has an API, so you can actually create containers programmatically, and you can get output from them. So one thing I made was a Telegram bot that actually lets you compile code on demand, sort of like Repl it, except in Telegram. But it creates a Docker container programmatically. It copies the files to that container, and then it compiles them and runs them within that container. It has a bunch of restrictions and stuff, and it's basically a sandbox away from the host. That's another cool thing you can. Lol Tyler 113. I did take computer science in school, but that's not really where I learned all of this. So, other Tyler. Oh my God, there's 2 Tylers in chat. So, can we set up? So you can just set up one powerful server to run all the Docker containers? Yes, you can. It's usually not a good idea though, but since I only have one home server, it's what I use. You can use multiple servers, yes. There's actually a Docker machine, which allows you to set up clusters. You can also use Kubernetes, which is compatible with Docker, but I like using Docker machine. I can link this. But basically, Docker machine does let you deploy multiple containers to a bunch of different servers, and it I think that it might handle load balancing. I actually haven't checked, but you can Google that if you want. There you go. Posted the Docker machine docs in there. But Docker isn't the actual thing that's handling all the orchestration of the servers and stuff. That's Docker machine, and then the load balancing would probably be handled by Docker machine. It's a good question. I'm not sure. They're probably there most likely is some configuration option that would let you do that, but usually when I oh my God, Code Steal, is that you? But usually when I do load balancing, I let the VPS provider take care of it, like Azure. I just let it take a look at the CPU usage and just do it from there. But so I'm not sure if there's auto load balancing. Let's take a Google real quick though. That's a good question. Oh, this is Docker Cloud. We don't want that. So, based on this Google search, there are ways, but I don't think it's official. So Pocket Band, what do you want to know about Docker? There's lots of Docker. Why is Docker's logo a whale? I'm not sure, but I know why. Let's take a look at the Docker logo. I'm not sure why it's a whale, but you can see by the containers, get it? It's carrying a bunch of containers. It's going to dock them onto your host machine, get it? Yeah, the whales are kind of slow, but the whale only needs to dock the containers onto your machine. Yeah, I'm not sure. Let's Google it. Why is Docker logo whale? Wow, I have fast internet. Guess people liked it. Not sure. Good. Giraffe. Whales are fun, that's why. Yes. So for creating a container, you can there's two main ways you can do it, or three. One is you can use the Docker command line. So this is probably the most preferred way when you're running something like a one-off container. So with the Docker run commands, we can run containers on the fly. And we can run stuff inside of them, like make directory, hello. It's there. When we exit, it's gone. But usually what you want to do is you want to use Docker Compose. And Docker Compose creates the containers for you, manages them, and does everything you need. So let's go back to that. Oh, I'm already in the workshop directory. Nice. So let's create a simple web server, like real quick. And I'll show you how we can do that. So this is out of the scope. I'm just writing this real quick. I think this is how you do it. How about just do this? There we go. There's our server. Wonderful. Let's create our Docker file for that server. I'm just doing this real quick. Now let's create a Docker Compose file. This is where we get to the container creation. Okay, let's create a service. We want a container that runs our web server, so let's name it web. And let's do build dot, which will tell it to just build the stuff that's in this current directory that has a Docker file in it. So let's make 80 30 30, I think is what I did. 30 30, yes. All right. So now let's tell Docker Compose to put up our server. Boom, it's up. Let's see if this worked. Oh, is that Nginx? Oh, it just cached. Don't worry, Nginx isn't actually running. Well, anyway, our Node.js server is running, but I never really set up any way to respond to requests, so I guess it's just going to sit there and time out. But as you can see, creating containers with Docker Compose is easy. You just define the stuff you want, and there's lots more options. So I'll put the Docker Compose docs inside of the Twitch chat. Very useful. I encourage you read them because there's lots of options that you might want to use. And the third way, besides running it from a command in Docker Compose, is through API, which might be useful if you have containers that you want to create to run like a one-off operation. What's a good project to make? Well, you can make a web server, like in our create a web server with Python workshop. You should take a look at that one. But no, seriously, a good project is probably a web server because you can learn lots of stuff about Docker. You can learn how to make a Docker file, how to use Docker Compose, how to expose ports to the web, because you want to do that with a web server, and you could learn about networking in containers, and you can learn about, if you want to add a database to it, you can learn about how to add another service to your Docker Compose file, a bunch of other stuff like that. It's really good, and I think making a web server is probably the best bet. If you don't want to make your own web server, say you're say you're not a programmer, you're just sysadmin, and you want to learn how Docker can benefit you, make your life a lot easier, you could look on the Docker store and look for a service that you use at your company or whatever, or something that you're just interested in, like GitLab. You can try putting up your own GitLab instance with Docker Compose and fiddling with a bunch of options from there. Any other questions? And everything I talked about here is in this document. So if you want to take a look at that and just go over everything. And I will be in chat basically all day. So if you have any questions on that document, let me know. All right. If no one has any more questions in chat, I'll say this is over. Hope you learned a lot about Docker. Thank you.